Hello guys, I wanted to make a quick video of what we covered yesterday and today in class. So hopefully this won't be too long of a video. But mainly I want to make sure you understand how to work those acceleration problems on that worksheet that I sent you. So first of all, we introduced a new concept yesterday called velocity. Velocity is just the speed of an object and the direction of its motion. So it's important to understand a couple key aspects of it. Speed can remain constant and velocity change if the object is changing direction. So if you think about a car going around a corner or going in a circle, it might have the same constant speed, but because it's changing directions, it's going to have a changing velocity. Okay. Now we calculate velocity the same way we do speed, so it's the same formula. Instead of speed equals distance divided by time, we can say velocity is distance divided by time. You just always want to make sure that you use the correct units and to include the direction in your answer. For example, if we look at question number 2 here, an elevator in a museum can travel 210 meters upwards at 35 seconds. What is the elevator's velocity? So what you would need to do, velocity is distance divided by time, so you divide 210 by 35, which equals 6 meters per second, but you also want to include the word upwards on that. Okay, so that's important that you do that. The next thing we talked about yesterday in class, we looked at some graphs, and when we graphed motion, and this was the bell ringer today, slope was the steepness of a line, right? You probably learned that in math class before. We can calculate slope by a couple of ways. We can call it the rise over the run, or we can say delta V, or the change in delta Y over the delta X. So the change in Y over the change in X. So in other words, distance, that's on that Y-axis in this graph here, over time, which is on the X-axis. So when we do the math on that, the slope of that line is going to also give you the speed that the object is traveling. So anywhere on this line, if you did the math, 8 divided by 4 is going to be 2. 10 divided by 5 would be 2. 12 divided by 6 is 2. So the answer to this graph was 2 meters per second. And so that's how you calculate. You can use the slope of the line to measure the speed. Now that's in a distance versus time graph. Now there's other ways of looking at motion, and so some different graphs here. What I wanted to point these out to you real quick, and again you can jot these down in your notes. The first one, you'll notice that line is moving at a linear, so it's going from 0 up till 12. We would say that the object is moving at a constant speed away from a reference point. So if the reference point's here, it's moving 12 meters away at a constant speed. Okay, so that's how we would describe that one. Here we would describe this one. You started off 12 meters away, but you've gone at a constant speed back to 0 here, which is the reference point. So the object is moving at a constant speed coming toward the reference point. This particular graph, what you'll notice is this, having this curve in it, is going to indicate that the object is speeding up or accelerating, which we're going to talk about in a little bit. This one here, what you'll notice as it's going up, the object is beginning to slow down. And you could calculate the speed of this object at different intervals, and you'll find out that it's actually slowing down until it's almost coming to a stop here and no longer moving. And so that's when it starts to level out, that's what's going on. All right. If we look at, I had a couple more here we talked about. Sketch a graph that would show an object not moving. So anywhere, whatever distance you are away from the reference point, you could draw a horizontal line, and that would indicate an object not moving. Time still is going to advance, but the object is not changing its distance because it's not moving. So that would just be this horizontal line. Now here in class I had a volunteer sketch a graph that would show an object moving at a constant speed, stopping, and then speeding up. So here, from here till about 3.5 seconds, it's moving at a constant speed. And then from about, 2.5. I'm sorry, that's 3 seconds. And then from about 3 to 5 seconds, it's not moving, it's stopped. So there's that horizontal line. And then it begins to speed up, so it's accelerating. So you see that curve. So that was a little bit about graphing motion with a distance versus time graph. Today, what we talked about introduced a new subject called acceleration. Okay, so acceleration, again, you want to put this stuff in your notes so that you have it for the test. Remember, for the actual test, I will not give you the formulas. So you will be responsible for those formulas yourself, so you can have those in your notes so that you can look those up and utilize those for the test. So acceleration is a rate of change of velocity over time. Sounds pretty simple, not too complex. The hardest part of acceleration really is this right here, this rate of change of velocity, because that's going to kind of be a little bit different, makes the whole formula look a little more intimidating. That's that rate of change, VF minus VI. We'll talk about that in just a second. So an object is considered to be accelerating when it speeds up, slows down, or changes direction. We typically measure it in miles per hour squared, meters per second squared, kilometers per hour squared. Those different ways we can measure acceleration. A couple things. Positive acceleration is going to be whenever it speeds up. Negative acceleration is going to be when it slows down. So when you get a positive number, you know that the object is speeding up, increasing its speed. When you get a negative answer on your question, you know that it's slowing down. Another term we might use is decelerate. So those basically mean the same thing, negative acceleration or deceleration. Here is your formula, A equals VF minus VI divided by T. So A is going to be your acceleration, time is the T, and then the VF, you have to think about starting what you start with and what you end with. The VF is going to be your final velocity, and the VI is your initial or beginning velocity. Okay, so you always want to make sure you get the VF minus VI. If you flip these, your answer will be wrong every time. So you got to make sure your final velocity minus your initial velocity when you're setting up that equation. We'll look at a couple of examples here. A car is traveling at 35 kilometers per hour, accelerates to a speed of 45 in 0.25 hours. What is its acceleration? So here's your formula. You're going to have basically your final velocity of 45, subtract your initial of 35, and you divide that by 0.25, and you'll get 40 kilometers per hour squared. Don't forget to put the correct units. And on your worksheet, also don't forget to show your work. That's important. Hopefully you have figured that out by now. And let's look at example number 2. A jet is traveling at 80 meters per second when it starts to approach a runway. It is able to land and park in 10 seconds. What is its acceleration? So your final velocity in this sense is going to be 0 because it's coming to a stop and parking. Its initial velocity was 80, so you're going to have 0 minus 80. Your time is 10 seconds. And you just simple math, negative 80 divided by 10 is going to be negative 8 meters per second squared. And that should make sense because it's negative acceleration because it is slowing down and coming to a stop. And then we have one more example I was going to show you here. This is for when you're asked to find final velocity. So that's typically the part that gives most people problems is trying to find final velocity. But if you know how to isolate a variable, it's not too difficult. A skateboarder has an acceleration of 1.5 meters per second squared. Starting from rest, if he accelerates for 2 seconds, what speed will he reach? So look what you're given. You're given the acceleration, which is 1.5 meters per second squared. You're given the initial velocity of 0 meters per second because he started from rest. See that right there. And then the time is going to be 2 seconds. So they show you what they've done here. They've isolated, in order to isolate final velocity, you're going to multiply both sides by time. All right, that cancels those out, so that puts time over on the left. So A times T equals VF minus A times T would equal VF minus VI. Okay, so what you do to get rid of VI, you're going to need to add it to both sides. So then that gives you this final answer of A times T plus VI equals VF. Hopefully I didn't confuse you with that. I just kind of misspoke a couple times. When you do the math, when you work this out over here, you'll notice that 1.5 times 2 is going to be 3. your initial velocity is 0 in this sense, so when you add that 0 to both times, it's not going to change your answer of 3 meters per second would be your final velocity. There's some examples on your worksheet today, so hopefully you can figure out how those work, and let me know if you need help with those, and I can help you with them. And they're not too difficult. Again, these are typically the hardest ones, trying to find the final velocity. So let's look at one more example. Here, this last one is one of those that we have to find the final velocity. A motorcyclist has an acceleration of 5 miles per hour squared. If his initial velocity is 45, what is his final velocity after 4 hours? So again, you're trying to find final velocity. His initial velocity is going to be 45, so you would set that up 0 minus 45. Okay, multiply both sides by time, which would be the 4 hours. 4 times 5 is going to be 20. So that should look like 20 equals VF minus 45. And then you would add 45 to both sides, and that would give you that answer of 65 miles per hour. Hopefully that made sense. It's easier to see that if I work it out on the board, but anyway. So I wanted to go over those with you so you can have a little bit of practice with those, and hopefully that will help you. And so let me know if you have any questions on any of that. I'll talk to you guys later. Bye.